can't, and it's plugged in here. Okay, so what I want us to do is here at the side, we're going to actually put on here our perfect squares. Okay? The perfect squares are the numbers that you can take the square root of. Okay? Those numbers we get when we take our normal numbers and we square them. So 1 squared is what?
1.
2 squared is? 3 squared is? 4 squared is? 5 squared is? 6 squared is? 7 squared is?
What are we going up to, 10?
We're going up to however far I decide to go up to. 8 squared is? 9 squared is? 10 squared is? 11 squared is? 12 squared is? 13 squared is? 14 squared is? 15 squared is? Now, in addition to like numbers perfect squares, we're also going to put a few variable perfect squares on here. Okay? And the reason that was slightly bit of a smart butt is because it's on the board, Ramsey. All right. So, if I have x and I square it, what do I get?
X squared.
If I have x squared and I square it, what do I get? If I have x to the third and I square it, what do I get? Why do we get x to the sixth? Because you have to multiply your exponents, okay? So that is a few of your perfect squares that will be important to remember, okay? Now, we're going to use those. So we have a difference of squares, which means our problem, we have binomials set up specifically with a minus in it, and they have 2 perfect squares on there, okay? And so it's a special type of factoring for binomials. So what I want us to do is we're going to look here. So it says first, make sure you have an actual difference of squares. It has to be subtraction and has to have perfect squares. Second, there is a rule that we can use to get that. So I want y'all to look over there at those at the answer, the factored form and the standard form of our warm-ups. What do y'all notice, if anything?
They're all the perfect squares of the
They're all the perfect squares of the numbers. Okay, because like 25, what squares to give you 25m squared? 5m. Okay, what squares to give you 1? 1. Okay, now, what do you multiply to get a negative number? A negative and a positive. Does that kind of match what we have written over there? It basically lets us have a shortcut to get to the factor, okay? Because we can see that it's 2 perfect squares and a difference. So what do we know is going to happen with those middle terms when we distribute out? They're going to cancel in those problems, right? So here, all we have to do is we're going to set up our parentheses. And what squares to give you a squared? What squares to give you b squared?
B.
What do you need to get a negative? A positive and a negative. So if you follow that procedure for any difference of squares, you will be able to factor it. Okay? So we're going to go ahead and we are going to do all of the
All the odds.
we're going to do all of the odds on the first page. Okay? So for number 1, for this one, What squares to give us a squared? What squares to give us 4?
2.
What do I need to get a negative?
Yeah, positive and negative.
There we go, we're done. That's how we factor these. When we have a difference of squares, that is all we do. Because we have to set it up. We have to use the positive and the negative so that the middle 2 terms, when we distribute, cancel out. For number 3, what squares to give us 81? What squares to give us x squared? What signs do I need? And that's all we got. For number 5, what do I do? I have a question.
I got a hint.
Is this a difference?
No.
So is it a difference of squares?
No.
No. If it's not a difference, it's not a difference of squares. All right. Now, what's the other method we've learned about factoring, especially for binomials so far? Which is called, what, we have to take out a greatest common factor. Yeah, we have to take out a GCF. Does that have a GCF we can take out? So if I cannot factor it, what does that mean?
It's prime.
So, not a difference. And no GCF.
What exactly does it have a GCF?
K squared and 25. So you can't factor anything out of it, and you can't break it into 2 pieces. So we're just stuck with K squared plus 25. That's as simple as we can get it. For number 7, is that a perfect square? Is it a difference?
Yes.
Then we're good to go. 9b squared. What's the square root of that? 3b. What's the square root of 100?
10.
What signs do I need?
Oh, positive and negative.
There we go. All right, for number 9. What squares to give us 16a squared?
4a.
What squares to give us 121?
11.
What signs do I need?
Positive and negative.
Number 11.
So if it's positive, like in the middle,
You cannot use this method because it is not a difference of squares. So this one, what squares to give you 4h squared?
2h.
What squares to give you 25g squared?
5g. This is my hand.
What signs do I need?
Positive and negative.
So that is our answer. Okay, I want y'all to do 8 and 10 for me real quick. For number 8, what should go in my first parentheses? 5x plus 7. What should go in my second one? 5x minus 7. The order of the positive and the negative do not matter. If you said 5x minus 7 times 5x plus 7, that is perfectly fine. Okay, that does not matter. All right, what is the first parentheses on 10?
X plus 9y.
And on the second parentheses?
X.
That is how we do these. So let's go ahead and flip to the back. So for number 13, what multiplies to give us x squared, y squared?
X, y.
What multiplies to give us 1? What signs do I need? And so even if we have multiple variables in one problem, we still do the same thing. Okay, for number 15, is that, what do I do for this one?
Oh, the same thing.
What do you do
Oh,
with
wait.
5? Is it prime? What do you do with 5?
Is it prime? That is the question. Is 5 a perfect square?
Mm-mm.
Can I factor out that 5 because it's a GCF? So can I factor it? No. It is prime.
That's my favorite drink.
And the reason for that is because that 5 is not a perfect square. And no GCF. So that makes it prime. Okay, now for number 17. So for 17, so you do k to the third plus times k to the third minus 4. Because k to the 6th is a perfect square, and it's the perfect square of k to the third.
Are we just doing all these?
We're doing most of them. I want y'all to do number 19 for me real quick. All right, for number 19, what multiplies to get, or what squares to give you 121 r to the 6th? What squares to give you 1? What signs do I need? Here we go. Now I want us to look at these evens real quick. I want us to do 20 together. So for 20, what squares to give us 64m to the 4th?
8 squared.
am what?
M squared.
What squares to give us 9n squared?
Can't even do it.
So we have a plus 3 and a minus 3. All right, I want y'all to do 18 for me real quick. What squares give us 4p to the 4th?
Square.
What squares to give us 25? What signs do I need? Here we go. Now I want us to look at number 21.
How do you do that?
That's all.
Number 21? Yeah.
On number 20,
It doesn't matter. That's just the way I wrote it. All right.
Oh. Oh.
So, 421. Is that perfect squares? Okay. Do I have a GCF though? What? 2. So we're going to pull that out. What is 2n squared divided by 2? Not just n, but n squared. What is negative 72 divided by 2? Now, what do you notice about what's inside the parentheses? That's a difference of squares, right?
And it's a perfect.
Or it's not a perfect square, it's a difference of squares with perfect squares. Right? Now, for this one, okay, we keep factoring in. It's just got an extra step. So we take that 2 and we leave that 2 in front, and then we do the rest of it just like we've been doing. What squares to give us n squared? What squares to give us 36? What signs do I need? There we go.
So that's it.
So you only put the 2.
We just leave the 2 in front. We just take out the GCF and just leave it in front.
So that's if it's not a perfect square, but it has a greatest number.
We check it for a GCF first and then go from there. Okay? And anytime we have a binomial, that's a good strategy. Check for a GCF first and then check for a difference of squares. When you have a binomial, so 2 terms, that's the 2 things you need to check. GCF, difference of squares. Because if it's not one of those 2 things, you can't factor that binomial. That's all you got for binomials. All right, for number 23, what's the GCF there? Let's talk real quick. So, when we have numbers that we may not immediately recognize our GCF for, there is a strategy you can use that will help you every single time. Okay? It takes a little bit of extra time, but if you don't know, what else are you gonna do? Sit there and plug every single number into your calculator and hope you figure it out? All right, so we have 32 and 18. I always start with this. It's 2. And so when I factor out the 2, what is 32s squared divided by 2? Then negative 18u squared divided by 2 is what? So then, is that a difference of squares inside? So let's factor it. What squares to give us 16s squared?
4s.
What squares to give us 9u squared?
3.
What signs do I need? There we go. Yes, ma'am. All right, for 25, what is our GCF? Okay, so 6. What is 24a squared divided by 6?
4A.
Okay, for 54b squared divided by 6, what is that?
9.
Can I factor that further? So we do 6 times 4a, not 4a, 2a plus times minus 3b. And that is what we do for difference of squares.
It looks really hard and then
that's kind of what factoring is. It looks really hard at first, but it's not. It's just we have to make sure we learn the basics and then we can do it. All right, so for number 27, what's my GCF? 5, I agree with that. Is that the only thing I can take out? N squared. Okay, because that n squared is in both of them, so we can go ahead and take that out. What is 80 n to the 4th divided by 5n squared? What was that? 16 what? N. Then we have negative 125 n squared divided by 5n squared. And that leaves us with a difference of squares. So we can keep factoring it. What should go in my first parentheses?
4
Okay, then what? What signs do I need? There we go. For 29, what's my GCF? 3p? Or could I take out 9? Can I take all a whole 9 out?
Oh, yeah,
So I'll do 9p, which is going to leave me with, Madeline, what did you say?
4.
P to the, we took out a p, so it leaves it with a 2, yep. Minus, what is anything divided by itself?
1.
So we get 9p times, okay, what else do we need in there? Plus 1 and, okay, 431. What's my GCF that can go into both of those? It is, or is it? Yeah, it's 4K. So 4K. So 16K to the 3rd divided by 4K is 100K divided by 4K is 25. So my answer would be what?
4K times 2K.
Again, the order of the minus 5 and the plus 5 does not matter as long as you have one of each. All right, your job is to factor 22 through 32. And if you need help, raise your hand.